Hi everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science. In this series, we have discussed about the advanced machine learning topics. Already we've seen what is machine learning. It's a subset of artificial intelligence that focus on the development of algorithm and models that enable computer to learn and make prediction or decision based on data. Today we are going to discuss about the concept learning. So concept learning involves acquiring general concepts from a specific training examples. For example, continually learn general concepts or categories such as bird, card, situation in which I should study more in order to pass the exam. Concept learning is the subset of so subset of objects or events defined over a large set. So each concepts can be viewed as a describing some set of objects or events defined over a large set. For example, the subset of animal that constitute birds. So alternatively, each concepts can be through of a Boolean valued function defined over this large set. For example, a function defined over all animals whose value is true for birds and false for other animals. So these are the known as the concept learning. Next, we see the task. So a concept learning task. So for example, here the task of learning the target concept, the days on which my friend Aldo enjoy his favorite water sport. So these are all the subsets. So here the task is how Aldo enjoy his favorite water sport in which day they prefer. So here the set of example days, each represented by a set of attribute. Then attribute enjoy sports indicates whether or not Aldo enjoys favorite water sport on this day. This task is learned to predict the value of enjoy sport for an arbitrary day based on the value of the attributes. So here the possible days, each described by the attribute sky. The sky is in subset sunny, cloud and rainy. So then the temperature. Temperature it is a warm or cold. So the humidity is a normal or high. So here the wind is a strong or weak. Water is a warm or cold. So the forecast is same climate or it's a changeable climate. These are the instances we are using in the to select the Aldo to enjoy the sports. So these attributes represent the based on the values of the other attributes. Next, hypothesis H. What is mean by hypothesis? So hypothesis representation shall be provided to the learner. In this case, let us begin by considering a simple representation in which each hypothesis consists of a conjunction of constraints on the instance attributes. In particular, let each attribute sky, air temperature, humidity, wind, water and forecast. For each attribute, the hypothesis will be either 0 or indicated by a question mark. Then any value is acceptable for this attribute or 0 specify a single required value. For example, warm for the attribute or 0 indicates by a 0 that no value is acceptable. So each attributes we consider the hypothesis value. If it is true, the value is 0. Another one is a question mark. So here the general and specific hypothesis. So we specify the hypothesis divided into hypothesis into form. One is a general, another one is a specific. So the most general hypothesis that every day is a positive example is represented by a question mark, and the most specific possible hypothesis that no day is positive example, that is a specific hypothesis. It is represented by a 0, 0 and all the attributes are 0. Next, target concepts C. Here, actually our task is Aldo is enjoying the sports water or not. So here the target concept is enjoy sport. So here the formula x gives 0, 1. When the learning target concept, the learner is presented a set of training example, each consisting of an instance X from X along with its X from capsule S. So along with the target concept value C of X. So the training example in this tabular column, instance of which C of X equal to 1 are called positive example, or member of the target concepts instance of which C of X equal to 0 are called negative. So if it is a Cx of 1 is a positive example, C of X equal to 0 means it's a negative example. So non-member of the target concepts, we will often write the ordered pad C of X to describe the training example consists of the instance X and the target concept value. Next, we see the inductive learning hypothesis. So, any hypothesis found to approximate the target function well over a sufficiently large set of training examples will also approximate the target function will over other unobserved examples. So, we come to the end of this section. I hope you enjoy this section. Thank you.